Hello class, this is a video tutorial on congruency proofs with examples now. So let's go straight into it. For the first one, I'm going to show you how to set it out again. So there should be a statement and a reason, okay, for each and every single line. Let's begin. So let's prove first that triangle ADB, so this triangle here is congruent to CDB. So we want to prove that these two, so this triangle and this triangle, are the same. So the first thing we're going to do is just go with the most obvious ones that we can do. So we have a single dash here and a single dash here. And just for simplicity's sake again, so I'm going to leave once again everything on my left hand side of my statements are going to be from ADB. It's congruent to triangle CDB. Remember again, what's in pencil will be erased, just so you'll see what it should look like at the end. Okay, so everything in ADB belongs on the left, and everything in CDB belongs on the right. Here we go. So we'll do statements in black, reasons in blue. Let's begin first. AD, so we have this single dash here, is equal to CD. And the reason for that is already given information. It's already given to us in the diagram. It's already drawn on in blue. In red. Okay. So that's one. We have AB is equal to CB. So we have AB is equal to CB. That, once again, is given information. So we have two sides. So now we either need an angle that's in between here, or we need a third side. So can we prove first that these two angles, this one and this one, are equal? I know I've drawn them on, but if we erase them, let's take a look. Are there any markings to tell us that these two angles are the same? Well, the answer is no. So we have to resort to a final side. So can we see a side that's equal in both triangles? So that's one side. That's the second side. Can we somehow prove that these two sides, this one and this one, are equal to each other? Well, if you didn't already see, they are actually the same side. So we can say that DB is equal to DB. And that there is not given information. We had to figure that out. And we said that that side is a common side. And then we have three sides, so we can say, therefore, triangle ADB is congruent to triangle CDB. And my reason is that it is three sides. Side, side, side. Okay, so now I'm going to erase these just so you can see what it should look like at the very end. So So that's what it should look like without the layout. But you can draw those in to when you first start off, just so that you get the hang of it. So this here is just the answer to question 1. So now let's prove the second one. Prove angle BDA. So this angle is equal to angle BDC. So they want to prove that these two angles are equal. Well, fortunately, we've already proven that these two triangles are congruent. As you can see that this angle is in between the single dash and the shared side. So they are corresponding angles. Okay, so that's an easy one. We can say that angle BDA is equal to angle BDC. And once again in blue, our reason. Corresponding angles of congruent triangles, which was already proven in our first question, or in our first answer here. So let's do one more here so you get the hang of it. This time I'm not going to draw out the layout. I'm going to go straight into the answer here. Let's take a look. This time I'm going to draw all of it in blue so you can see what it looks like once you get the hang of it. Let's start with the easiest one. So PSTs are going to be on my left, RSQ is going to be on my right. So we have ST, so that's already given to us. So we can say ST is equal to SQ. That's given info. I'm just gonna make that shorter. Now, okay, let's see if we can figure out some more. Well, if we remember properties of geometric figures, angle PST is equal to angle RSQ. So I'm going to draw in pencil what I'm referring to. This angle is equal to this angle. And if you can remember why, it's actually because they are vertically opposite. Okay, so I'll write that in. Angle PST is equal to angle RSQ. The reason for that is that they are vertically opposite. Okay, and if you don't remember this, I'm going to link this to another video of mine. I've explained this in another video. So we have a side, we have an angle. There are no marked sides here, but if you take a look, those two arrows means that these two are actually parallel lines. And we can use that to our advantage. Okay, if we take a look, once again, if you can remember properties of parallel lines, this angle PTS, okay, I'll mark it again, I'll erase these two dots. This angle is actually equal to this angle. Okay, that's because they are alternate angles. So I can use that. PTS is equal to angle RQS, and they are alternate angles. Once again, if you don't remember this, I will link you to another video explaining the angle relationships in parallel lines. So we have now a side, an angle, or angle, angle, side. Because of these three, we can say, therefore, triangle PST is congruent to triangle RSQ. And the reason that we did was two angles, angle, angle, and a side. So angle, angle, side. Now we move on to question 2. We want to prove that PT, so that side there, is equal to RQ. Well, since we've just proven that these two triangles are congruent, we can clearly see that this side corresponds with this side. So we can just make that quick statement. PT is equal to RQ, and that is corresponding sides of congruent triangles. Okay, so I hope that gives a good outline on how to do congruent proofs. Best of luck.